Hello everyone. Welcome to the Learn Circuit tutorial. This is the third video on node analysis. In this video, we will practice node analysis using the following two examples. Let us start with example 4. We need to determine I/O, which is labeled in the circuit. There are 3 steps to use node analysis as follows. Let's start with our usual questions. How many nodes are there? Which node should be selected as the reference node? Which node voltages are known? Which node voltages are not known? Pause the video and think about those questions. In this example, there are 4 nodes. The step 1 is to select a reference node and label non-reference node voltages. We select the bottom node as the reference node, and its voltage becomes 0 volt. Then, the voltage at node 3 is 3 volt because of Vs2. If the reason here is not clear to you, I recommend you to watch the first video on node analysis. We don't know the voltage at node 1. Then we just label it. We do not need to label V3 because we know its node voltages. Do we need to label V2? We definitely do not know the voltage at node 2. But, do we need to care about its voltage? No, not at all. We know its current, which is determined by the current source. The current is 1 amp, and it enters node 1. That is all we need to write the KCL. Now step 1 is done. Step 2 is to label current directions and write KCL. The current directions for the R1 branch is determined by the current source. The current direction of I/O is already labeled by the question. We only need to label the current for our 2 branch. Let's label it flow away from the node. We are now ready to write KCLs for node 1. And we will use equation B. The KCL equation for node 1 is 1 amp, that is IS1. This term has a positive sign because it enters node 1. Minus V1 over 6, that is I2. It is minus because the current leaves node 1. Minus V1 minus 3 over 6, that is I/O. It is minus because the current leaves node 1. Equals 0. In step 3, we can solve the equation. The solution is V1 equals 4.5 volt. Finally, using Ohm's law, we can determine I/O. A common mistake is try to determine the current I1 go through R1 using V1. For example, I1 equals to V1 over R1. Now, let's move on to example 5. The question asks us to determine node voltages and branch currents. Note that this circuit has 2 current sources, but no voltage sources. We list the 3 steps as follows. Again, our usual questions. How many nodes are there? Which node should be selected as the reference node? Which node voltages are known? Which node voltages are not known? Pause the video and think about those questions. I am going to go a little faster. Let's go ahead to select the reference node and label the current directions. There are 3 nodes in the circuit. We selected the bottom node as the reference node. Because there are no voltage sources, the 2 non-reference nodes are both unknown. We labeled them as V1 and V2. For the branches with the current sources, both current directions and magnitude are already given. We just use them. Do not try to use Ohm's law to find their current, which is a common mistake. I repeat, both current directions and magnitude are already given for the 2 branches. We also labeled 3 currents I1, I2, and I3. Because the current sources already determine their current directions, it is not practical to label all the currents flowing away from the nodes. We are ready to write KCLs for the node 1 and node 2, and we will use equation B. KCL for node 1 is IS1 minus I1 minus I2 equals 0. I1 and I2 have a minus sign because they leave node 1. Express the equation based on V1 and V2. The equation is 1 amp, that is IS1, minus V1 over 8, that is I1, minus V1 minus V2 over 2, that is I2. Then the equation equals 0. KCL for node 2 is I2 minus I3 minus IS2 equals 0. I3 and IS2 have a minus sign because they leave node 2. Express the equation based on V1 and V2. The equation is V1 minus V2 over 2, that is I2, minus V2 over 6, that is I3, minus 2 amp, that is IS2. Then the equation equals 0. In step 3, we can solve the two linear equations with two unknowns. We will solve V1 equals minus 2 volts and V2 equals minus 4.5 volts. They are both negative, but it is okay. Finally, we can determine the branch currents. I1 is minus 0.25 amp, I2 is 1.25 amp, and I3 is minus 0.75 amp. That's it for this video. I hope you find it helpful. If you have any questions, please leave a comment below. Thank you for watching. Visit learncircuits.net for more information. See you next time.